we were discussing about shift down parsers, and we concluded that majority of the top down parsers are of the type shift reduce parsers. Now we will take two categories of shift reduce parsers, and out of these two categories we'll take one each of them for further exploration. So one is operator precedence parser and the other one is called as LR parsers. Operator precedence parser and LR parsers. LR parsers can be classified into three: simple LR parsers or SLR parsers, LR parsers are the most general LR type, and LALR parsers, look ahead LR parsers. Let us see what is meant by an operator precedence parser now. Now, textbook says that operator precedence parser is an efficient way of constructing a shift down parser. But this will work only for a small class of grammars, CFGs. There, the principles of operator precedence will be applied to create a bottom-up parsing activity. Now, to qualify as an operator grammar, there are certain requirements. An operator precedence parser will work with an operator precedence grammar, an operator grammar. And if the grammar is of operator type, grammar type, an operator precedence parser can parse it. Now, these are the two features of an operator precedence parser. One is that there should not be a production with an epsilon element in it. Second property is that no two non-terminals will be adjacent. So if A and B are two non-terminals, we cannot have a body of production such that AB is there. When A and B are adjacent, we can read it as AB. So additionally, there should not be no production which it has an epsilon element. Let us see this example. See, E derives or E gives E plus E, E gives E into E. E can be written as follows, like this, and E can be written as minus E, E derives ID. So you can see that none of these productions, in the body of the productions, none of these productions have an epsilon element in it. Second property is that no two non-terminals are adjacent. You can see that between these two E's, there is an operator called plus. Similarly, you can see in the all other cases, no two non-terminals are adjacently placed. So this particular grammar qualify as an operator grammar. This grammar can be used to do operator precedence parsing. Now we know that when we have operators like this, and when we make a scope for sub-expressions, there can be ambiguities. When an expression such as A plus B into C comes, there has to be a rule about what to compute first and what to compute next. Now, this feature, to employ this feature, we will make use of, we will enforce precedence and associativity rules. This fact we have mentioned earlier, and we have seen that one of the methods of removing ambiguity is also setting precedence. Now, in the operator precedence grammar, a precedence operator precedence table will be created, and using the operator precedence table, parsing will be done as we have done all bottom-up parsers. There will be a stack, there will be shift operation, and we will do, there are certain rules for that. Now, so we are getting to now operator precedence parsing. We have to know how an operator precedence parser works. So now we have answered this many questions. What are the type of bottom-up parsers? What is meant by an operator grammar? What are all the essential features of an operator grammar? What are all the essential features of an operator grammar? Then what outline an example for operator precedence grammar. All these things we have answered. Now we will answer how an operator precedence parsing operations can be done. There are certain steps for that. Like we created M table, we have to in top-down parsing, we have to create an operator precedence table in operator precedence parsing. For that, there are certain steps, and those steps will be discussed in the coming portions of the class. See, here we told about setting operator precedence relations. There are these three operators, less than, equal to, and greater than, with a dot placed here, a dot within the less than, and a dot with greater than, a equal to plus a dot. This is how these operators are used for specifying the precedence relationship between operators in operator precedence grammar. Now this is less than, equal to, and greater than. Suppose that there are two terminals called A and B. If A less than B, it simply says that A has lesser precedence than B. That means A yields precedence to B. Yielding means A is having lesser precedence than B. B has got higher precedence. A has got lesser precedence. Suppose that A and A equal to B is specified. In that case, A and B have same precedence as in multiplication and division. We know that multiplication and division have equal precedence, and addition and subtraction have equal precedence, whereas multiplication enjoys higher precedence over addition. So A greater than B, A takes precedence over B. This sentence is clear, whereas yields is a new word. That's what I told you. This is just opposite. Yielding means A is having lesser precedence. Same less than, equal to, and greater than can be read. So if you read like that, these meanings will be clear for you.